Something extraordinary is happening right now in the global energy race, and most people in this country have absolutely no idea how deep it goes. A company based in the city of Ningde, on the southeastern coast of China, just did something that battery scientists have been trying to crack for over 2 decades. They took an element that you can literally find in ocean water, in table salt, in the dirt under your feet, and they turned it into a mass-production battery, powerful enough to drive a full-size passenger car for over 240 miles on a single charge, with the cold weather performance that leaves anything currently sitting in your garage looking like 1980s technology. That company is CATL, Contemporary Amperex Technology Company Limited, and the battery is called the Naxtra. And in the year 2026, they are not talking about doing this. They are already doing it. In this video, we are going to dive deep into CATL's Naxtra sodium-ion battery and show you exactly why this technology is not just an energy story, not just a chemistry story, but a geopolitical earthquake that every American who cares about our industrial future absolutely needs to understand right now. We will look at where this technology comes from, what it actually does, why Washington has been caught flat-footed, and what the next 5 years could mean for energy independence, both China's and ours. Welcome to Chinese Revolution. It is now June of 2026, and the global race for battery dominance has reached a decisive tipping point. As an analyst watching these massive international developments unfold, it is clear that the landscape of energy storage, electric mobility, and critical mineral supply chains is undergoing a structural shift unlike anything we have seen since the invention of the lithium-ion battery itself. And the center of gravity for that shift is not in Detroit. It is not in Silicon Valley. It is in a coastal province of China called Fujian. While Washington debates energy mandates and supply chain legislation, Beijing has already industrialized the next generation of power. That is not rhetoric. That is the recurring thesis of everything you are about to hear. Let us start with a number that will set the stage for this entire conversation. Lithium. Right now, the electric vehicle industry, and by extension, the energy storage industry runs almost entirely on lithium. Every major battery in every major electric car sold anywhere in the world today is a lithium-based chemistry. Lithium iron phosphate, lithium nickel, manganese cobalt oxide, variations of lithium this, lithium that. The entire multi-trillion-dollar clean energy transition of the 21st century has been built on top of one element that makes up just 0.0065% of the Earth's crust, according to available geological data. That is a razor-thin foundation for a civilization's energy future. And the deposits where you actually find lithium in commercially viable concentrations are not evenly spread across the globe. They are concentrated in South America, the so-called Lithium Triangle of Chile, Argentina, and Bolivia, and in Australia, and to a meaningful degree in China itself. The United States has some domestic lithium resources, but our refining and processing capacity has historically lagged far behind demand, and the price of this critical material is anything but stable. According to data from Caixin Global, battery-grade lithium carbonate prices in China increased 47.7% in 2025, with prices at various points running 84.9% above mid-year lows. That kind of volatility is not just an inconvenience, it is a strategic vulnerability for every company that makes batteries, every automaker that builds electric cars, and every nation that has bet its energy future on a supply chain it does not fully control. Now here is where sodium enters the picture, and where CATL's Naxtra starts to become not just interesting, but genuinely significant. Sodium is not a rare element. It is not a strategic choke point. Sodium makes up approximately 2.3% of the Earth's crust, roughly 400 times more abundant than lithium, and it is distributed broadly and evenly across every continent on the planet. The world's oceans hold 500 to 1,000 times more sodium than lithium, according to geological estimates. Here is something that should make every American sit up and pay attention. The United States has the world's largest known reserves of soda ash, which is a key sodium precursor material. That means a sodium-based battery economy, done right, is one that our domestic industries could actually participate in without depending on a supply chain routed through Beijing, or Santiago, or Canberra. The raw material advantage is profound, and it is sitting right here in our own backyard. But raw material abundance means nothing without the technology to make it work. And that is precisely where CATL's Naxtra represents a genuine engineering breakthrough. CATL began its sodium-ion research program all the way back in 2016, according to the company's own disclosures. Over the following decade, they built out a research and development investment of nearly 10 billion yuan, that translates to approximately $1.4 billion, and they developed and tested close to 300,000 experimental battery cells in the process. This was not a quick pivot or a press release science project. This was a decade of grinding, systematic, high-investment engineering work. And the result is a battery that, as of April 2025, CATL unveiled at its inaugural Super Tech Day event in Beijing under the Naxtra brand name. Let's talk about what the Naxtra actually is and what it actually does, because the specifications here are what matter and they are remarkable. CATL's Naxtra passenger EV battery achieves an energy density of 175 watt-hours per kilogram, which the company describes as the current benchmark for mass-produced sodium-ion batteries. To put that in context, the previous generation of sodium-ion cells that CATL first showed the world in 2021 achieved 160 watt-hours per kilogram. The Naxtra has pushed that number up by nearly 10%, and it has done so at a scale that makes industrial production viable. Why does energy density matter to you as a driver? Because it determines how far you can go on a single charge without carrying a battery pack that weighs as much as a small aircraft carrier. With CATL's cell-to-pack system and intelligent battery management electronics, the Naxtra enables a pure electric driving range exceeding 400 kilometers that is just under 250 miles on a single charge in current production form. And CATL's roadmap targets 500 to 600 kilometers in future iterations, which translates to roughly 310 to 370 miles. Think about that for a moment. The drive from New York City to Boston is a little over 200 miles. You could make that run in a Naxtra-powered vehicle and still have range to spare. But the range number, while important, is actually not the most strategically significant thing about this battery. The most significant thing is what it does in the cold. Anyone in this country who has ever lived in Minnesota, or Michigan, or upstate New York, or really anywhere that gets a real winter, knows exactly what happens to an electric vehicle when the temperature drops. That battery range you were promised in the showroom. It shrinks, sometimes dramatically. A Michigan winter can take a lithium iron phosphate battery pack and cut its usable range down substantially. Some real-world tests suggest losses of 20 to 40% in genuinely cold conditions. That is not a minor inconvenience. For someone commuting an hour each way through a snowbelt, that is the difference between making it home and being stranded on the side of a highway in January. The Naxtra battery was specifically engineered to solve this problem. CATL's Naxtra operates reliably across a temperature range spanning from -40 degrees Celsius all the way up to +70 degrees Celsius. -40 Celsius is also -40 Fahrenheit. It is the same number at that point. That is colder than most weather stations in Alaska ever record. And at that extreme temperature, the Naxtra passenger EV battery retains 90% of its usable power. 90%. Compare that to lithium iron phosphate, and the gap is striking. Under extreme cold conditions, the Naxtra's discharge power is reported to be nearly 3 times that of a lithium iron phosphate battery of the same capacity. 3 times. If you are trying to convince someone in Green Bay, or Fargo, or Buffalo that electric vehicles make sense for their daily life, this number is the one that matters most. The cold weather fast charging performance is equally important. One of the most frustrating things about electric vehicles in winter conditions is that charging slows down dramatically when it is cold outside the chemistry simply does not accept current as quickly. CATL's sodium-ion chemistry facilitates faster ion transfer between cathode and anode compared to other electrochemical systems, and the Naxtra battery can achieve 80% state of charge in 15 minutes at room temperature, with the ability to maintain fast charging performance across that entire operational temperature range down to -40 degrees. Now let us talk about why this battery is structurally different in a way that has enormous economic and geopolitical implications. The Naxtra does not use cobalt, it does not use nickel. Both of those metals have been significant pain points in the global battery supply chain. Cobalt, especially, given that the majority of the world's cobalt production comes from the Democratic Republic of Congo under conditions that have drawn serious human rights scrutiny, and that refining and processing of cobalt is heavily concentrated in China. Beyond that, the Naxtra uses aluminum foil instead of copper for its current collector, which gives it a meaningful cost advantage over lithium-based alternatives, because aluminum is far cheaper and more broadly available than copper. Combine cheaper raw materials with a chemistry that avoids cobalt and nickel, and you have a battery that, by analyst estimates reported by Dongguan Securities, could see cell costs fall below 0.4 yuan per watt-hour in 2026. That is roughly 6 cents per watt-hour in US dollars, approaching current lithium iron phosphate pricing, at a fraction of the environmental and supply chain cost. What do you think about this shift away from lithium as the backbone of the battery industry? Have you ever experienced a situation where battery performance failed you in cold weather, or where the cost of an EV just felt out of reach? Share your personal experiences and detailed thoughts in the comments section right below. Now, I know some of you might be thinking about leaving the video right here because you feel like battery chemistry is getting a little deep into the weeds, but trust me, you will want to stay because the geopolitical implications of what CATL is doing with the Naxtra and what it means for American energy independence and our domestic industries is about to get very concrete and very personal. Let us step back and look at CATL as a company, because you cannot understand the Naxtra without understanding the machine that built it. CATL was founded in 2011 in Ningde, Fujian Province. In the roughly 14 years since its founding, it has become the single largest battery manufacturer on the planet. According to data from SNE Research, CATL's global power battery market share in 2025 reached 39.2%, ranking first globally for the 9th consecutive year, and remaining the only battery provider anywhere in the world with over 30% market share. To put that dominance in perspective, the second-place company, BYD, held a 16.4% global share. LG Energy Solution, the top non-Chinese competitor, held 9.2%. CATL is not in a race. CATL is lapping the field. In 2025 alone, the company shipped 661 gigawatt-hours of lithium-ion batteries, a 39% increase over the prior year, and posted a record 42% surge in annual net profit. Their global production capacity reached 772 gigawatt-hours, operating at a 96.9% utilization rate. These are not startup numbers. These are the numbers of an industrial superpower operating at full stride. And now, at the peak of that lithium empire, CATL is deliberately investing in the technology that could restructure the entire playing field beneath it. That is either the boldest strategic move in modern industrial history, or it is the clearest possible signal that they know something about where this technology is going that the rest of the world is only beginning to understand. The commercial milestones of the Naxtra have come fast. On the 21st of April 2025, CATL unveiled the Naxtra publicly at its Super Tech Day event, describing it as the world's first mass-producible sodium-ion battery. This represented, in the company's own words, its transition from laboratory breakthrough to large-scale manufacturing. By September of 2025, the Naxtra had become the first sodium-ion battery worldwide to achieve compliance with China's new national safety standard, known as GB 38031-2025, covering safety requirements for power batteries of electric vehicles, passing rigorous testing, including thermal diffusion resistance, bottom impact, and fast charging stress. That certification is not a formality. It is the green light for full commercial deployment in the world's largest electric vehicle market. Then, in February of 2026, the story shifted from the lab and the test center to the highway. On February 5th of 2026, in Yakeshi, Inner Mongolia, which is about as cold and demanding a real-world test environment as you can find anywhere on Earth, CATL and Chang'an Automobile jointly unveiled the world's first mass-production passenger vehicle equipped with sodium-ion batteries. That vehicle is the Chang'an Nevo A6, and it is set to reach the Chinese market in mid-2026. This is a historic milestone because it closes the gap between experimental chemistry and something a family can actually buy at a dealership. Sodium-ion technology is no longer a concept, it is a product. The strategic ambitions behind the Naxtra extend well beyond passenger vehicles. CATL's roadmap, which the company outlined at its supplier conference in December 2025 and has since elaborated on publicly, targets 4 major deployment areas for sodium-ion batteries in 2026. Battery swapping infrastructure, passenger vehicles, commercial vehicles, and utility-scale energy storage. That last category is particularly significant for the United States because the single biggest challenge our domestic power grid faces as we add more wind and solar capacity is storage. The ability to capture energy when the sun is shining and the wind is blowing and release it when demand is high. CATL's grid-scale sodium-ion battery for energy storage, unveiled in 2026, carries an energy density of around 160 watt-hours per kilogram, a system energy conversion efficiency of 97%, and a cycle life of over 15,000 charge-discharge cycles while retaining 80% capacity. To translate that cycle life into something more familiar, 15,000 full charge and discharge cycles at 1 cycle per day is roughly 41 years of continuous daily operation. That is not a battery you replace. That is infrastructure. The commercial scale of CATL's sodium-ion ambitions was made unmistakably clear on the 27th of April 2026 when CATL signed what has been described as the largest sodium-ion battery order in history. The company announced a 3-year strategic cooperation agreement with Chinese energy storage integrator Hyperstrong for 60 gigawatt-hours of sodium-ion batteries for energy storage projects. To calibrate that number, 60 gigawatt-hours is roughly equivalent to half of the total volume of energy storage batteries CATL shipped across the entire world in all of 2025 in a single contract. Industry observers quoted by the South China Morning Post have already compared the implications of this deal to what DeepSeek did to artificial intelligence assumptions, the idea being that wide-scale deployment of sodium-ion in production could dramatically reduce costs and reshape the competitive economics of energy storage globally, in the same way that DeepSeek disrupted assumptions about the cost of developing advanced AI. And it is worth noting that no other sodium-ion manufacturer in the world, not Heine Battery in China, not Natron Energy in the United States, not European players like Altris or Faradion, has secured an order anywhere remotely close to this size. That brings us to the question that every American watching this video should be sitting with right now. Where is the United States in all of this? The honest answer is, we are behind. Not hopelessly behind, not irreversibly behind, but behind. The Department of Energy has placed long-duration energy storage high on its agenda, and national laboratories, including Argonne National Laboratory, are actively supporting sodium-ion research. Scientists at Argonne are working to improve battery lifetimes and simplify production processes, and there are American companies genuinely working in this space. Natron Energy, based in North Carolina, describes itself as the only commercial sodium-ion battery manufacturer with operations based entirely in the U.S. In August of 2024, Natron Energy announced a planned investment of $1.4 billion to build the first sodium-ion battery gigafactory in the United States, in Edgecombe County, North Carolina. Peak Energy, a U.S. company, has deployed sodium-ion battery energy storage systems in Colorado and signed agreements for installations in Wisconsin. A company called Centropic Power is building out manufacturing capacity in the United States, with pilot projects expected in mid-2026. These are real efforts, and they deserve recognition. But let us be honest about the scale differential. CATL alone has already invested the equivalent of $1.4 billion in sodium-ion research and development. The same figure Natron Energy is raising to build a single gigafactory, and CATL did that research over the past decade while simultaneously becoming the world's dominant battery manufacturer, scaling to 772 gigawatt-hours of production capacity, and signing a 60 gigawatt-hour sodium-ion order in a single deal. In the race between a company that started in 2016, invested $1.5 billion in research, built up global manufacturing dominance, cracked the mass production engineering challenges, certified the product to national safety standards, launched the world's first commercial sodium-ion vehicle, and signed the world's largest sodium-ion order, and a startup still building its first gigafactory. The gap is not a detail. The gap is the story, and the market data reinforces just how rapidly China is moving to cement its position. Industry projections cited by Sinopec estimate that China's sodium-ion battery market will expand from around 10 gigawatt-hours in 2025 to roughly 292 gigawatt-hours by 2034, an average annual growth rate of approximately 45%. By the end of this decade, according to those projections, China is forecast to account for more than 90% of global sodium-ion battery output. According to CATL Chairman and CEO Robin Zhang, the company's long-term expectation is that sodium-ion batteries will replace 30 to 40% of the existing lithium-ion market share. Think about what that means. CATL controls 39.2% of the global lithium battery market today. If sodium-ion takes 30 to 40% of the total battery market, and CATL dominates sodium-ion production the way it dominates lithium, which it is currently on track to do, then the company's effective control over global energy storage expands rather than contracts. Meanwhile, the company is already developing what it describes as its sixth-generation sodium battery, and CATL's chief scientist Wu Kai has publicly stated that solid-state batteries could enter small-scale production by 2027 with lithium-air batteries which have a theoretical energy density of up to 12,000 watt-hours per kilogram, rivaling gasoline formally designated as the long-term next-generation target. While Washington debates energy mandates and argues over EV subsidies, Beijing has already industrialized the next generation of power. That is not a metaphor. It is the timeline. Now here is the strategic irony that every patriotic American should find deeply uncomfortable. Sodium, the foundational raw material of this entire technology, is one of the most abundant elements on Earth. About 70% of the world's sodium can be found in seawater. The United States, as noted earlier, holds major reserves of soda ash, a key sodium precursor. We have the raw material. We have world-class university research programs studying this chemistry. We have national laboratories doing exactly this kind of work. Argonne National Laboratory has active sodium-ion research programs. What we do not have, right now, is a CATL. We do not have a company that has made the $10 billion commitment to turn that chemistry into a gigawatt-hour scale production reality, while simultaneously winning nearly 40% of the global battery market. Our manufacturers have the inputs. China has the industrial system that turns inputs into dominance. There is a parallel here. that anyone who remembers the story of American manufacturing over the past 40 years will recognize immediately. Our domestic steel industry, our television manufacturing, our consumer electronics, our solar panel production in each of those industries. The United States had the foundational science, had capable workers, had the raw material access. What happened in each case was a gap in the industrial policy, will to build and sustain the manufacturing capacity needed to compete. CATL is doing in batteries what Japan did in consumer electronics in the 1980s, and what China did in solar in the 2000s, moving from technology adopter to technology definer, and doing it faster than the incumbent assumed was possible. The implications for our domestic industries are stark, and they are immediate. Every legacy battery company, every domestic automaker that relies on imported lithium cells, every energy storage developer trying to build American grid resilience, they are all operating in a landscape that CATL is actively reshaping. The question for our manufacturers is not whether sodium-ion becomes commercially significant. That question was already answered in February 2026, when the world's first mass-production sodium-ion vehicle was unveiled in Inner Mongolia. The question now is whether American companies can find a viable competitive path, or whether the pattern we have seen play out in solar, in consumer electronics, and in lithium batteries plays out again. One area where there is genuine reason for optimism is supply chain independence. Unlike the lithium supply chain, which routes through Chile, Argentina, and Chinese refiners, a domestic sodium-ion industry in the United States could theoretically source its core materials from within our own borders. The U.S. has the raw materials. The U.S. has the research talent. What our domestic industries need is the kind of sustained, patient, strategic investment that China's industrial policy has directed at CATL and its ecosystem for the better part of a decade. The race is not over, but the scoreboard in 2026 is not flattering to the home team. Looking at the BYD side of the ledger is also instructive here, because CATL is not even alone. BYD, China's second-largest battery company with a 16.4% global market share, announced in July 2025 a pilot production line for sodium-ion batteries in Xining, Qinghai, with an initial annual capacity of 30 gigawatt-hours. BYD's third-generation sodium-ion platform reportedly achieves over 10,000 charge-discharge cycles and has addressed previous challenges with high-temperature performance. Both CATL and BYD view sodium-ion as a strategic hedge against lithium price volatility, and both are scaling simultaneously. By analyst projections, the combined production capacity of CATL and BYD alone will represent approximately 60% of all planned global sodium-ion manufacturing capacity through 2027. The two largest battery companies in the world, both Chinese, are converging on the same next-generation chemistry at the same time. That is not a coincidence. That is industrial strategy. For the American consumer and the American driver, the practical implications of the Naxtra and the sodium-ion revolution break down along two dimensions. The first is cost. If sodium-ion cells achieve cost parity with lithium iron phosphate, as analysts project they could, by 2027, the economics of electric vehicles change meaningfully, particularly at the lower end of the market. A battery that costs significantly less to manufacture, uses abundant and geopolitically stable raw materials, and requires no cobalt or nickel, could help bring the sticker price of a basic electric vehicle down to a range that actually competes with a used internal combustion car without requiring a government subsidy to make the math work. The second dimension is cold weather performance, which is specifically relevant to the tens of millions of Americans who live in the northern half of this country. The person in Duluth or Detroit or Denver who currently looks at EV ranges and does the winter math and decides it does not work for their life, that calculation looks different with a battery that retains 90% capacity at -40 degrees. The Naxtra was essentially engineered as a solution to their specific objection. The challenge is that American consumers who might benefit from this technology are currently blocked from accessing it by tariff structures and trade restrictions that limit the import of Chinese-manufactured batteries and vehicles. That is a legitimate national security calculation, and not one to be dismissed lightly. But it also means that unless American companies move quickly to develop competitive alternatives, our consumers end up paying more and getting less, while the technology, in their tax dollars indirectly funded through national laboratory research, gets commercialized across the Pacific at a scale we cannot match in the near term. The future of battery technology will likely be defined by a dual chemistry era, where sodium-ion and lithium-ion coexist and compete, each finding its appropriate applications: sodium in shorter-range urban vehicles, in commercial fleets, in grid-scale storage, lithium in long-range premium applications, and high-performance uses. CATL's own leadership describes this as the dual-star era, with sodium and lithium developing in parallel. But here is the critical geopolitical reality. The company that controls both stars controls the energy future. And right now, with a 39.2% market share in lithium, the world's largest sodium-ion commercial order, the world's first mass-production sodium-ion vehicle, and a 10-year development investment, CATL is in position to do exactly that. While Washington debates, Beijing has already built the next generation of energy storage. That is the recurring thesis, and the evidence in 2026 supports it completely. So here is the question I want to leave you with today. Given that sodium is one of the most abundant elements on Earth, and given that the United States has domestic raw material resources that could support a competitive sodium-ion industry, do you believe our domestic manufacturers and our policymakers will make the sustained, a serious commitment needed to compete in this space before CATL's head start becomes permanent? And if you are a driver in a cold weather state, does the Naxtra's cold weather performance story change how you think about electric vehicles in your own life? If you found value in this deep analytical breakdown, please remember to hit that thumbs up button. Share this video with someone who cares about American manufacturing and our energy future, and subscribe to the channel so you never miss another exclusive look into how global technology is evolving and what it means for the competition between the United States and China. Thank you for watching, and we will see you in the next announcement.